All right. Thank you, everyone, for coming to this session. My name is Kevin. I'm working for a consultancy company just called Berge, actually just 2 floors up from here. We are doing a lot of machine learning and deep learning, and today I'm going to show you sort of like a boilerplate workflow that you can actually use. You can actually take it with you. I'm also going to share a repo link. Feel free to take photos during the presentation. And yeah, it's not going to be anything fancy. I try to prepare all kinds of different demos, and then it failed a lot, so I sort of like dumbed it down a lot. But I think the workflow is there, and that's what's really important. Just to set some expectations, this is going to focus on the actual pipeline rather than developing the next state-of-the-art algorithm or anything like that. And I'm going to assume that most of you have some knowledge of machine learning workflow as well as TensorFlow. There'll be a lot of code. It's already pre-written. I'm just going to run a lot of it. But I'm not going to go through line by line. And the cloud service that we're going to use today is a Google Cloud Platform. And I just like to point out that, full disclosure, we're biased towards Google Cloud because we're a partner with Google working on this. Okay, so today in this demo, very simple, the one that I dumbed it down in the last couple of days, we're going to predict a baby's weight based on a lot of factors. So it depends on the mother's age. I can actually show you if we go to. So the data set is actually available publicly, and there are actually a lot of data sets. All these tables here that you see are actually freely available. Those who are interested in what that is, you can also dig into doing your crypto trading stuff. But today we're not going to do anything that exciting. We're going to look at natality, and you can actually see here. Is it zooming in properly on the screen as well? Yeah. So the year that the baby was born, and this is kind of weird way of saying male and female, is female Boolean. I didn't create this data set. And then what we're mostly interested in is the weight of the baby written in pounds. This is the American data set. Okay, let's go back to what's happening here now. So given a different number of factors associated with the pregnancy as well as the baby's mother, the data set size is roughly 20 gigabytes. And if you go to this link while you're actually logged into the Google Cloud Platform, this particular data set will be automatically added to the whichever Google Cloud Platform project that you have it open. So this is usually the first step in machine learning workflow that you probably, we're not going to use the entire data set, and then as you saw in the table schema, there were a lot of different types of data that maybe we don't really want to use. So we're going to use a SQL queries, and then we're going to just sort of trim down the data set, and we're going to do some other pre-processing here is that oftentimes, we want to actually simulate, okay, all these data sets actually have male and female, because those are Boolean. It cannot be anything else. But we want to also simulate cases when you don't actually get any ultrasound data. So, like, before the birth, you don't actually know if the baby's female or male. But we still want to be able to predict the baby's weight. So during this pre-processing step, we're going to also just create. We're going to basically duplicate all the data and just get rid of the gender. So we just kind of like double the amount of data with the different parameters. And normally, if you are an experienced TensorFlow user, you normally want to change all your data into what's called as a TensorFlow TF records format, which is in binary format. But in this particular demo, I'm going to just store them in CSV. It won't be actually live, because when I ran this, it took like 2 hours to actually pre-process. But I'm going to show you sort of the beginning of the step, and then I'll jump to the results that I have already saved. And this whole pre-process will be running on a scalable cluster. So it's scalable by means. So I should also point out that all the tools that I'm going to use today are called serverless operations, meaning that we will not be actually provisioning we're not provisioning number of CPUs, memory, or anything like that. Google Cloud Platform will actually take care of, depending on how heavy each processing load is, it will actually just scale up and down automatically, and then you will, of course, get charged accordingly. But of course, it doesn't scale up infinitely. You can always set it like a maximum, how many cluster, like a maximum of 5 cluster. If that's how much you are comfortable with. So just to show you before we actually get to the demo, it's just going to show you some of the results that I've already saved. We're going to be pulling the data from BigQuery. They'll be streamed into Dataflow, and then Dataflow will convert them into CSV while also generating these non-ultrasound data, and then put them on the Google Cloud Storage, where we can still access through the web. And this is sort of, this was actually the result that I got when I trained April 9th, is that yesterday? It scaled up to 24 instances, and the 24 was actually the number that I said it was trying to go even way above. But it just wanted to show you that the tool that we're using it has this option to scale up and down, and I don't think it's something that if you have an on-premise infrastructure, it's very difficult to manage sometimes. In the machine learning part, the neural net that we're going to implement is called wide and deep model. And then if you follow this link there, that actually has a research paper about how it actually combines wide learning as well as a deep learning being just a deep, fully connected neural networks. And we're going to package up this model into a trainer task, and then we can actually submit this to what's called as a Google Cloud ML engine, which will then also take care of all the scalability. It will pull as many resources as it needs up to the maximum capacity that I define to train the model. And then afterward, we can actually see if we can make actually predictions with the trained model. And as the final step, we're going to also create a front end, like a web page, which will then actually then send JSON request to this trained model, and then we'll get the prediction data back, and then we'll be able to actually see, we'll be able to actually predict a baby's weight. So this is roughly the workflow that it's going to be taking. So inputs that are coming from BigQuery, pre-processing will be happening in Dataflow, and Dataflow is actually just another name for what's called as Apache Beam, and feature creation will be done in TensorFlow as well as with the training model. And once the model is trained, we're going to pull it to the web application. All right, so let's hope this is going to work. So this demo is mostly going to be worked in this product called Cloud Data Lab, and this is essentially, if you're familiar with the Jupyter Notebook, this is Google's version of Jupyter Notebook. But the best part of it is that it's actually already has all the most of the big data or data science libraries pre-installed, as well as TensorFlow. So you don't have to go through all the compilation of TensorFlow on your own. So we're going to just quickly look at the data. So this is the these are the features that we're going to look at. Okay, so we definitely want the baby's weight. We need to look at the gender, mother's age. Polarity means if it was a single or twin or even triplet. This also means until the delivery, how many weeks the mother has been pregnant. And we're also going to create a hash of the birthday so that we can actually use the hash to sort of mix up the data, so we're not actually, when we're actually dividing the data set between training set and then the evaluation, we're not sort of biasing by in any order. And we're going to also look at just the babies that have been born since 2000, and I believe the data set is up to 2008. Okay, just going to run them so that they have it saved. Okay, so in this particular step, before we actually get into data flow, what I'm actually trying to do is I'm actually using pandas to do the pre-processing that I will be actually doing with the data flow. But with data flow, I'll be doing it on the entire data set. But we also want to create a very small subset of the data set so we can also test out our TensorFlow model. So I'm going to also, just using pandas, create very small CSV file with maybe just 100 babies in them or something. I don't need to run those. So we can write out, and you can see that we have train.csv, eval.csv. These are very small file. Okay, so now let's get into TensorFlow. I'm just going to have to run this again. So you can actually see that, yeah, okay, list all the CSV files stored in this folder. So now we're going to import TensorFlow. And in this particular, so right now we're now getting into modeling, actually building the neural network and then the linear model as well for the wide version. And we're gonna train only for 1,000 steps because this is only just for the integrity check. We need to make sure that everything is running smoothly before we actually submit it to the Cloud ML Engine, because once you actually submit your model to train on ML Engine, if it fails, even if it fails, it still like charges you for whatever compute resources that you have used there. So you don't want to go into you don't want to end up finding an error half an hour later and then it has already charged you for 100 krona. So there are going to be just 4 functions, pretty simple. The first one is just going to be read data set. And if you're familiar with the TensorFlow, you can basically see that we're just dividing between train functions as well as evaluation. And this is an input function that gets actually fed into the estimator API later on. Okay, so the second function was the get y deep. Third one was serving input function, and this is probably the most interesting one. And for the wide and deep learning, we're actually basically just using pre-defined API from the estimator, and then this is actually the equivalent version of wide and deep model. And with all the parameters defined, and for now, we're also going to just use two layers of deep neural networks. And we define this, and now we can finally train. Is it working? Can everybody actually see all the text? It's fine? Yeah? So yeah, earlier on we defined the steps to be just 1,000, so it's pretty soon there. And it's currently just a saving into baby weight underscore trained here. Okay, while we're waiting, once you actually have the model all defined, and then we're actually still working in this Jupyter notebook, and then you might be wondering, okay, how do I actually go from this to creating your own Python module and then submitting it to cloud ML engine? So what we have done here is, so this is sort of the folder structure you need to have, and then all the details you can actually find it on Google Cloud Platform page. And if we go to this model, you can actually see that this is just a one Python file that contains all the 4 functions that we've just seen: read data set, get wide deep, serving input, and then train and evaluate. And this is the package that we're going to be putting it up onto the Google Cloud. Okay, now it has successfully ran up to 1,000, and we can, that was the TensorFlow, TensorBoard, but we're going to skip that. Let's move on to, okay, now we know that we have the model that is actually working. Now we just need to create the subset of data set. So here's the query again that we're going to save. We don't need to look at that. There are a couple of other options that you can actually do. You can actually pull data directly from BigQuery to TensorFlow. You could also just go into BigQuery's web UI and then save CSV files that way. But what we're actually doing here is that we're also trying to create this synthetic data of not having ultrasound cases in real life. And in that case, we actually need to define an actual script and then running it on Dataflow. I don't know what I just did. Oh, yeah. Okay, so this actually, this one block of code here has already defined the entire pipeline of the pre-processing, and then has actually submitted the job to Dataflow. So we can actually refresh this and then see if sometimes it can take a little bit of while. But I can just show you that this particular job was what I actually ran prior to this demo. And it's basically reading 2 different divided data sets from BigQuery, and then adding in this CSV function here, or block here, it's actually adding this adding this augmented data without actually having the gender known, and then it's just putting it out and then saving it into this storage folder here. So it's a pre-processed, and you can actually see evaluation data, train data, and all of it. Okay, so if you have now all that, we can now try to. So this was actually just to show that what are the functions that are defined in the baby weight trainer model.py. And this is a step actually also before you submit anything onto the cloud. It's actually locally running it, but let's skip not actually running it, but you know that you should always run it locally before you submit anything to the cloud. And here is the part where you define, so this is like a bash script. The actual interesting line here is that you just call Google Cloud ML Engine and then submit. And this is the trainer dot. So trainer was the folder name, and then the task.py, that's the Python module name here that we have defined. And once we submit this, you should be able to actually see a job running here. And if it succeeds, it will come to green, and then you can actually see that it ran for about 2 hours. It's very trivial data, but it tends to take quite a bit. But at the same time, I wasn't using GPUs or anything. I was just using 4 CPUs at the same time. And I would also like to point out that there is an option to do hyperparameter tuning. So it is actually able to defined what parameters you could actually use. But this process also takes very long time. So once you find, you can actually define exactly what batch size you want to use for also neural net size as well. I tried to run this for 6 hours, and then it didn't really succeed. But there's definitely an option and an interesting area. So running a little bit out of time. Now So once this train job is done, I will show you the result of it. Let's see. So in this job directory that we have defined, okay, so wherever our bucket is defined, baby weight, trained model, so our trained weight should be saved there. So if we go back, we're already at baby weight. We should go to trained model. And if you can actually see all the model checkpoints. So you could actually also keep training on if you had to cancel it or something. But since it's also running on the cloud, it's not, when you're running on premises or in your own local workstation, often you have to cancel it. But I think the beauty of running stuff on the cloud is that you can just keep it running. Nobody's going to take away your job. And this export here is where our saved model is saved. So when we actually deploy this, we're going to link to that folder. So this is where we just were, the bucket place, baby weight, train model, export. Okay, so what is it that I'm actually about to run here is that sorry, I'm just jumping around too much. So now that we actually have a trained weights, we still need to, there's another capability or functionality of Cloud ML Engine is that, so there's a section called jobs, and then there's another place called models. And this is where you actually deploy the model. And the model is just saved there. And this already includes all the structure, neural nets, and everything. And then you just need to provide the right format of the input. And this is what we're going to actually link our web application to. So this code part basically creates this model as well as the version. So you can actually also save it into different versions as well if you have multiple models. So with the trained model already now deployed on Cloud ML Engine, we're now going to run the web application on what's called App Engine, and these are the this is the configuration that we're going to use. We're going to tell App Engine that okay, our app is going to be running in Python, and then it's actually defined here, and you can actually we're actually defining that okay, the model name is GAIA ML demo baby weight. We would like to use version 1, and the prediction function is defined here, and then it's just calling the model that's saved in the Cloud ML Engine, and it's going to receive the output back and then show it into the front end that's defined in this App Engine. So this is the bash script that's been written. It's just going to install all the dependencies, and then it's just going to create the app based on this YAML script, and we should be able to access this at this link once it's deployed. Okay, so we're gonna just run deploy.bash. The error is only there because I already have it deployed, but we're just going to override it. Before I do that, I will just show you quickly. So there is an app already up and running. I think we got 5 minutes left. We'll override that. All right, let's see. Okay, so it actually terminated my other app engine, and now it's actually running the new one. We just need to go to this link. Okay. Come on. Okay, so now we have this front-end web page defined. Let's pick some random numbers. And when I click predict, App Engine is going to package this input into JSON and then make a request to ML Engine, and then it's going to receive the output back and then display right here. So 7 pounds. I don't know if that's normal or not. We can do some other. Okay, if the mother was younger, everything else the same. 6. Okay, what if it was triplets? Definitely lighter. Or if it's overdue, oh, still a healthy weight. But anyways, I hope this was somewhat informative. Apologize for jumping around a lot. This pray definitely worked. So what we just did here was, as I just explained, it's just a GAE, meaning Google App Engine, is just making a web API request to this cloud ML engine, and it's handling all the infrastructure, containerization or whatever have you. You need to do all this, DevOps that people talk about. You don't have to worry anything about it. You just set it up here, and your trained ML model is good to go. So if you want to try this, I think you can just freely go and then sign up, and then you get roughly around 2,000 krona. This demo cost me only about 500, so I think you can do at least 4 demos. And that was it, and thank you very much. And if you want to know anything more about the whole cloud workflow, come talk to us at the booth just outside. Thank you.